Hey, it's Mr. Eason here. In our Zoom meetings this morning, we worked with with line plots. And so I'm going to show you guys a couple of examples we did with line plots, and that way you guys can kind of have a better idea of what's going on. Might help you do the optional work that I'm going to post up as well. So in this particular scenario, a class bounced a ball 18 times and recorded the data in a table. So they bounced it and they saw how high the ball bounced, and they put all their information down. And so we're going to be putting it into a line plot. So we're just going to go through the list and we're going to put an X over every time, or for every piece of data. So I'm going to put an X over the 3 first because there's a 3, then an over a 6, there's a 6, and a 5, because there's a 5. And we're going to go through the whole list, putting an X where they go. So 5, 5, 1, 5, 5, 1, 1, 4, 5, 1, 4, 5, 6, 4, 6, 6, 4, 6, 5, 2, 4, 5, 2, 4, 6, 6, 5, 6, 6, 5. Okay, and then we have some questions down here. How many balls bounced 3 meters or higher? And so in that case, we're not just looking at the 3 meters, we're looking at anything from 3 or up. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 balls bounced 3 meters or higher. How many balls bounced less than 3 meters? So we don't include the 3, we have to go less than 3, and it'd be 1, 2, and 3. And then, for some reason it says D, but it really should be C. Based on the data, if we bounce the ball another time, what is the height likely to be and why? And so this is where you kind of look at your graph and you think, well, out of 18 tries, it bounced 5 meters high the most, and so that's a pretty good prediction that it's going to bounce 5 meters high. You could even say it's going to bounce 5 or 6 meters high, and that would be like an over 50% chance of getting it right according to the data here, okay? And so we're just going to look at another quick example. This is going to involve fractions. So we looked at a chart, and we filled in some information. Basically, these students were going to the pool, and they were keeping track of how long they were swimming, and so we filled out the chart with, I think, 24 different pieces of data, ranging anywhere from 1/2 all the way up to 2.5, and we answered some questions. So the first question we answered, and was based on just these 5 X's right here, and the question was, how long were those 5 children in the pool all together? And so we had 2 children in there for 3/4 of an hour, 1 in there for 1 hour, 1 in there for 1 1/4 hours, and 1 in there for 2 hours. And so you can do this a couple different ways. Might be a good idea to kind of start combining some things. We might combine the 1 and the 2 hours into 3 hours. We might combine the 1/4 and the 6/4, because that's 3/4 plus 3/4, into 7/4, or 1 3/4. And then we add this amount with this amount. And we also include this extra 1 whole right here from this 1 1/4. And we get 5 3/4 hours, or how long the students were in the pool for. So this is just a brief overview of kind of what we did with the line plots. The optional work is going to ask you to look at some data to create your own line plot and then answer some questions based on the data. So hopefully you guys will be good to go for that. This has been Mr. Eason with Homework Help, or Classwork Help, and I will see you next time.